Welcome to JACS in Conversation. It's my great pleasure today to have Professor Vivian Yam of the University of Hong Kong. Welcome, Vivian.
Okay.
Professor Yam obtained a bachelor's degree with first class honors and a PhD from the University of Hong Kong, where she is currently the Philip Wilson Wong Professor of Chemistry and Energy. She's also a chaired professorship at the university. She started her career as a faculty member in the Department of Applied Science at the City Polytechnic of Hong Kong, which is now the City University of Hong Kong. She returned to her alma mater in 1990. She has received many accolades. She's an elected member of the Chinese Academy of Sciences, a member of the U.S. National Academy of Sciences, the Academic Europea, founding member of the Hong Kong Academy of Sciences, and of course, as to no surprise, a recipient of many awards and accolades from numerous institutions. And if I were to go through the whole list, I'm afraid we would need a whole hour just to go through them. So I'm going to pick some highlights. She's a laureate of the 2011 L'Oreal UNESCO Women in Science Award. She is the recipient of the Joseph Mickel ACS Award in Photochemistry, the Royal Society of Chemistry Centenary Medal, as well as many others. Her research interests are extremely varied, including the fundamental, inorganic chemistry, organometallic chemistry, supramolecular chemistry, photochemistry and photophysics, and the more applied. So she does chemistry in nano materials, functional materials, optoelectronics, and energy. Clearly doing cutting edge research in relevant and timely areas that'll make the quality of life for all of us much better in the future. She has served as associate editor for inorganic chemistry for 12 years and currently serves as vice president of the Chinese Chemical Society and the chair for Women Chemists Committee. So Vivian, we're delighted to have you here today. So let's start off with some general ones. What is your vision for chemistry and the discipline?
Yeah, I think chemistry is a central science. I'm a true believer that chemistry indeed is a central science. We really look at things at the molecular level. And of course, the molecules consist of atoms coming together. So we need to understand the structure and bonding. We understand the electronic structures. And all these are very important for us to understand the structure, property, function, reactivity relationships. And so being a central science, because we look at things at the molecular level, we try to understand different things. And then we can really work at the interface of with physics, with engineering, in terms of materials, energy, related matters. We also work together at the interface with biology and medicine to come up with new drugs, new diagnostics, therapeutics, imaging, sort of agents, and many others, treatments, and a lot of biomedical applications. So I really think that chemistry is a really very important central science that binds the different disciplines together and really working towards also sustainability, catalysis, I think we should have a better image in people's mind rather than always associate us with, pollution, you create all the stuffs that could not be degraded. But actually, chemists have been doing a lot of good things for the world. And so I think really we have a long way to go, of course, but I think we can really participate in trying to underpin and try to meet the grand challenges that we are facing today in terms of the environment, in terms of energy, materials, climate change, sustainability, anything, you name it. There must be chemistry.
What kind of advice would you give for the new generation of academics or just chemists in general?
Also, I think it's really a very challenging world now, but there are many scientific questions, scientific problems or challenges that we must work together to solve. And I always believe science has no borders, right? And so we should work together. And I think for the young people, so I would suggest that they should not be just very narrowly focused. I know people working in their area, they just want to focus in their area and they don't even within chemistry, different subdisciplines. Some people were very narrowly focused. It's not bad. It's not a bad thing, right? They go in greater depth. But then the breadth is also so important because you need to communicate with people within chemistry and beyond chemistry. As I mentioned, it's a central science. You need to talk to physicists, engineers. You need to talk to the clinicians, the biomedical people, biology people, earth science people, atmospheric people, whatever. And nowadays with AI, you also need to communicate with the statistics people, data science people, and of course the theoretical people. So you need to really read very widely and to understand, at least not in very great depth, what the other disciplines are doing and what the other disciplines can offer in order to come up with solutions. And so you need to develop the common language. You need at least to know some jargons. We are talking about molecular orbitals, right? Homo-lumo. The physicists are talking about density of states. Actually, it's talking about the same thing, right? But different terminology. So at least you need to learn some sort of terminology jargons of the different disciplines and try to talk to different people and read as widely as you can. Actually, in my research group, I always ask my students, not just focus on the journals that we used to publish, we used to read, but also read something that is totally looks like is irrelevant. But actually, sometimes you look at these papers, they will be able to inspire you to think of something beyond what you have learned.
Those are words of wisdom there that you packed. A lot of that statement from thinking outside the box, extremely important. I totally agree. How did you first become interested in chemistry?
As I mentioned, I like to analyze things in a very objective way. I like the objective sort of way of thinking and analysis. And of course, when I was young, I was really sort of attracted to the wonders of science. Particularly, I was very much attracted to this very colorful world. And that's why I'm working with light-matter interaction and, very strongly absorbing compounds or emissive compounds and so on. And actually, when I was in the primary school, I was also, I broke a thermometer, mercury thermometer at home. And then I collected the mercury droplets. And it's so amazing. I mean, when they coalesce and then when they flow around, and it's a metal, it's a liquid. So I was really very much attracted to trying to understand these, the wonders of science, and chemistry is really dear to my heart, because when we were even in junior high school, then we started with qualitative analysis, mixing different solutions, very colorful. And then particularly the mercury droplets really amazed me, and I really love chemistry.
Yeah, you're right. I think I would answer the same way. It's the colors, the smells, right? The transformations that make it fascinating. How do you think chemistry could be, or science in general, actually, more inclusive and diverse?
Yeah, science needs to be inclusive and diverse. And particularly the EDI thing, I think I'm very much for it, because after all, so there are, of course, people talking about gender balance and then age, different races, different nationality, so many things. So I think we should sort of embrace diversity, as diverse as possible. Because what happens is that, say, if I just talk about gender, statistically, 50% will be male, 50% will be female. Of course, there are some deviations. But if you are going to give away 50% of your talents, then this is not the right thing to do, right?
Right.
And of course, same for different races, different nationality, and different age group. So we need to be as inclusive as possible to find the best of everyone. So everyone must have something good, must have something not so good. So if we can capture the talents, the best of everyone, why not?
So, Vivian, you're a global phenomenon. You're known all over the place for your first class science and for the various leadership roles that you have taken on. What's the secret of your success? What do you think was critical to the immense success you're enjoying?
Yeah, thank you. So I guess maybe it's my personality. So I'm a very sincere person and pretty straightforward person. And so people don't need to guess what I'm thinking because I'm so straightforward. And I really treasure everyone in a way. The students, I really am grateful to them. Without the students and the postdoc, their hard work, I mean, I won't be able to achieve what I have today. And also my collaborators, my mentors, everyone. And I make new friends. I really treasure all the friendships. And I was telling I have two daughters. I was telling, I really enjoy to be an academic. And I said that what else could be better than an academic? People are paying you to do your hobby, to demonstrate your ideas, right? You come up with an idea, you really want to demonstrate your idea, and then there will be funding to do so, and then you are paid a salary to do so. What else in the world could be better? No matter which place I go, I have friends everywhere in the world. You know, it's chemistry that connects us together, as you mentioned, right? You go to any place, then you are welcome by your colleagues in other places, and our common hobby, our common language is really chemistry that connects us together. And so this is so good in a way that I think this is my ideal best sort of, I won't call it a job, it's my hobby. I never thought I'm having a job or an occupation. I'm doing my hobby every day.
What's your favorite JACS publication from your own research group?
Actually, there are many more than one
That's good.
because I love
That's
JACS.
all good.
So if you are going to ask me, that is must be one that I ask my student to look at, then it will be the perspective because it will really come with the history of the evolution of how we come up with some solid state polymorphism and some sort of aggregation all the way to coming with supramolecular soft materials, sensing different morphologies and non-classical crystallization and things like that. So then that's the perspective in 2022, I think. Yeah.
So Vivian, you contributed greatly to JAC's success with as an author, as a referee, and you're also, of course, a member of the editorial advisory board. What does JACS do well, in your opinion? And the follow-up question will be, of course, what can we do better as we move forward?
So I think JACS has been doing great. It is my favorite journal. So the reason why is because I think, obviously, for ACS journals, and not only JACS, it's always handled by active researchers who are editors. So this is very important. They know the chemistry well, and that's why they will be able to find the right reviewers. Of course, nowadays reviewers, sometimes they are too busy, but at least they will be able to identify the best reviewer. And these reviewers really are relevant to your subject matter. So they will give very relevant critiques, some very critical reviews, some not so critical. But as I said, I'm really open-minded to criticism because only when you really have very rigorous sort of critiques, then one will be able to think deeper or do additional experiments in order to make the science more solid and more rigorous. So I guess JACS is really a journal that really is multidisciplinary in a way because it covers all subject disciplines in chemistry, as well as the fact that it's very solid, very high quality, of the top quality and highest rigor. So very professional. And I think the sort of turnaround time is also really reasonable. So that's why I really enjoy very much publishing in JACS and reviewing for JACS.
So as you know, I totally agree. And this is something we discuss extensively at the various meetings, how we can make the experience a more meaningful one, especially for the young, early career investigators. So lately, we make sure that when an early career investigator submits a manuscript, that it goes out for review, because I think they can really benefit from the input, the feedback that they get from the referees, whether it's positive or negative. It's good to always get that kind of feedback, especially when you're early in your career. You also suggested something that I've been giving thought to. Would you recommend ACS, and I like to think JACS as well, to others, and why?
Oh, this is very obvious. I always recommend already. And why? Because as I already mentioned, it's a very professional handling and active researchers, scientists being the editors, as well as the fact that it's really of the highest rigor. And a lot of times you choose really the right reviewers that will be able to make critical reviews, which is actually constructive. So I think I really also want to convey the message to the young people, because sometimes they are pretty much upset about critical reviews. But actually, I think this is where people are trying to bring better things for you to think about, very critical things that you might have not thought of. And if you take it in a very positive attitude, this is the way how you can improve your papers and improve your research directions and how you do your research. I think this is very important. So that's why I always said people should not be overly defensive.
Yeah, no, you're right. It's a way to take it to the next level, right? And moreover, it indicates that the reviewer found your science interesting because they took time out to think about
Yeah.
it and to provide both constructive and sometimes critical analysis. Can you share some instances where you found inspiration from JACS or in another ACS journal?
Obviously from JACS and as well as other ACS journals. So I was thinking my work on a lot of this supramolecular assembly involving metal complexes, metal-metal interactions. I mean, it all stems from the papers from Steve Lippert on this platinum terperidian system, and of course then the platinum blues, Steve Lippert again, together with Jackie Barton, and then the platinum pop, where Harry Gray, and of course Vinnie Miskalski, Chi-Ming Chi, these people, and Roundhill, they look at this platinum pop and talk about these metal-metal interactions, and also I also work on the GO1 interactions, the orophilicity from Schmidt-Bauer and Pekka Picchio, who try to analyze the theoretical work and all that. And yeah, I think I'm very much inspired by all these. And also Harry Gray also put up this rhodium-1 tetrakis isocyanide when I think Ken Mann was his student. And it's again, they form oligomers, very beautiful color, emission changes. I mean, all these really inspire me. And then, but then because I was trained as a coordination chemist as well, and I tried to learn more about organometallic chemistry, and then I thought I can really contribute in a way of looking at organometallic excited state chemistry, luminescence, and then when I incorporate all these aryl groups, alkynyl groups, LQ groups, they improve the solubility of these coordination compounds tremendously. And then leads to something so interesting, because in the past, usually people are looking at this metal-metal interaction in the solid state. But now we'll be able to manipulate it even in the solution state because of their enhanced solubility. So it opens up a totally new area in a way. So I'm very much inspired by all these early works.
I'm thinking back to my Caltech days where, yeah, Harry Gray was talking about platinum P-pop, and he ended up gifting my group actually a book on sort of the photochemistry of metal complexes, which was fascinating to look at.
But I want to bring it beyond that.
Sure.
So now looking at supramolecular polymers and assemblies, but all these are inspired by them. So it's important, I think, We need to be inspired, and we need to inspire. And that's why I also like teaching a lot, actually. And another thing I want to tell the young people, some young academics, they really want to focus totally on research. But I think in the university, teaching is also very important. We want to mentor and educate the next generation to pass on the torch. And I always try to convince my younger colleagues, I said, teaching actually helps research. And sometimes people don't believe me. I think so, because the simplest question asked by your students is the most difficult to answer. And it really drags you to think deeper into the most fundamental thing in order to be able to answer those questions and to think deeper, right? You can read by yourself. You can learn by yourself. Once you have a strong foundation, that's why, because science and technology is moving forward every day in a very fast pace. If you just understand what you understand today or memorize things today, you won't be able to catch up with what the world is, the science and technology are going. So that's why you need to continue to learn. So say, for example, I have a topic I want to teach, and then I don't know myself. I purposely put it into my teaching. And then I have to force myself to learn quicker and to learn deeper than the students. And when the student asks some questions I don't know how to answer, it makes me learn even deeper. So I think this is a good way to force yourself, or not to force yourself, to speed up your own learning pace.
Hearing you talk, it sounds like we have a lot of shared views, perspectives, and experiences. I certainly have had projects that were initiated by a question in a class, right? That an undergraduate asks, and you realize I don't really know the answer to that, right? Or the experiment hasn't really been done. You've been assuming all this time that whatever idea that you were trying to teach the student. Vivian, it's always a great pleasure to read your science, and it's inspiring to converse with you about a wide range of topics. I'm afraid the time has come to an end in the JACS conversation with you today, but I want to express my gratitude for taking time out to engage, and it's great talking to you.
Yeah, and thank you so much for engaging me. I really enjoy very much the conversation, and maybe we still have a lot to talk about. And please do come to Hong Kong. You're welcome.
And you're always welcome here.
Yeah, and so yeah, thank you so much. Thank you for taking your time out.